My today's topic for this talk is Flutter and Flame, an introduction to game development in Flutter. Okay. So before we go on, my name is Shree Bhagwat, and I am a CEO of Codemy, which is a client-based company. We develop applications and build softwares. And this is my social shares. You can connect me. Regarding this talk, if you have any questions, I'll be more than glad to help you all. Okay. So today's agenda I have kept pretty simple. First, we will build the game, and then we will play the game. It's just as simple as that. Okay. So before we start directly jumping into what we are or how we are going to build, let's first check what we are actually going to build over here. So this is a simple Mario Run game. I'll just start click and just a minute, let me just refresh it once. So it starts from the start. Yeah. And we have this. So this is the basic Mario which can jump, collect coins, and also die. Okay, so this is the general, simple, basic game that we are going to build. So first, what is a game? It's a form of interactive entertainment where players must overcome challenges. And objective of the game is to win the challenges and to follow the set of rules and to reach at the endpoint. So the main challenge of this game that we are going to build today is simple: just survive and try to make as much high score as we can. Okay. So we are going to start with Flame. So this was a basic introduction to Flame, like why I'm using Flame and how Flame helps in creating game development very easy and fast. Okay. So Flame is a modular Flutter game engine that provides a complete set of solutions for games. So like it's kind of a wrapper where it has everything that we need to create a game that can run in Flutter. Again, Flutter is cross-platform, so the game that we build in Flame and Flutter will run on all the platforms that Flutter supports. So it will run on your web, it will run on Mac, Windows, phones, everything. All you have to just take care is a bit of the responsiveness, which I have actually skipped because then it would be too lengthy. But yeah, fine. This is their web page about Flame. You can just go to this web page and check the documentations. It's pretty simple. Just have to left side they have the column that we have to follow. That's it. Now what we are going to cover in this talk, basic about Flame concepts, is the file structure. What is game widget, game loop, and one of the most important part is components. What are components and how we create those components. So the file structure for Flame is simple. We have to have an assets folder, and inside assets folder we'll have to have audio folder, images folder, and tiles folder. And Flame will directly get the assets located in these folders directly. You don't have to specifically mention the entire path, and we can load the caches from the Flame engine directly into our application, or let's say game in this concept. Okay. And the next part is game widget. So now what is a game widget? A widget that runs the game. As we all know, everything is widget. So a widget which is running the game is called a game widget. And it is a widget which has to be at the root generally when we build game. But again, we can keep that widget anywhere inside our widget tree. Technically, I prefer keeping it at the root so that whenever you are running your Flutter app, it will directly start with the game engine and you can initialize your game at the start itself. Okay. We can also have multiple game widgets depending on which game widget you want to run on what part of your application. So basically, I've created a game widget, and in the run app, I'm just passing the game widget that we have created. Okay. And the game widget has to be extended by Flame game, so that whatever context are there or whatever components that we need inside our game and the Flutter components the Flame components that can be used inside and initialized directly from the start. Okay. And Flame game is one of the most commonly game class used in Flame and recommended base class. As in base class as the start of the class. Like you have to extend the flame game as our main game. Okay. Now the life cycle is over here. So we have functions which runs only once, and we have functions which keep on running on every tick. So the most important function that we have is called as on load, because that is the start of the life cycle. And after that, we also have update function which keeps on running at every tick. Because see, in a game you have to keep in mind that each and every second the character moves, there is some changes going on, and we have to keep on updating that changes onto our screen, be it animation, be it movement of the character, or be it any interaction the character does. Okay. So the onload function is important to start the game, and the update function is important so that we can update the state of the game continuously. And each and every component that we are going to build will follow this life cycle. So that's why this life cycle is pretty much important for us to understand in general how game development works. Okay. The on, resize, on load, on mount are called in order. Okay. This is the order these functions are called. The on game resize function helps to resize the game according to the size of the screen. So let's say you have a small phone, it will take that size and then build the screen size depending on that. Then we will load and then we will mount the game. And update and render functions are continuously called every second, or let's say every tick in this. And on removed function is called when we dispose the game or when we exit from the game. Like we can exit from the game and still our app can be running if you are using game widget inside a widget tree, or you can straight away come outside of the game. Okay. Now, game loop. As I said, game loop is an infinite loop which processes the user's input. For example, when I'm hitting the key, like left key, right key, it will take that update and the game loop will continue call the update and render function. The update function will update the state of the game when the user inputs, and the render function will render everything on that screen or on that layout. Okay. It helps to make the game responsive, and the real-time feel of the game is nice because of this updates and render function. Now, components. As Flutter developers, we know everything is a widget, but when it comes to game, everything is a component. Whatever you see on the screen is actually a component. Okay, and components are the basic building blocks of Flame game, similar to widgets. And all components inherits from the abstract class called as components. Simple, but this picture will help you understand the components and widgets aspect very clearly and in a simple form. Okay. The component lifecycle, again, as I said, the game lifecycle and the component lifecycle is one and the same. Okay. We also have on game resize, on mount, and update and render over here. If removed, then the on remove function will be called, and on load function is also there where if you want to reload the game, and everything is just like the previous slide that I've explained. Okay. Yeah. Now in components, we have multiple types of components. Like there is a timer component, there is a particle component, but the most important components which I feel is the one that I have did a red square box. It has a sprite components and sprite group components and etc. Okay. Positioning components are the components which help us to actually position the object or the component on the screen. If you want it in the center, left, right, where you want, it helps us in that way. HUD, H-U-D, okay. It helps us to create overlays, like if you want to have a menu like main menu or the pause and play button, whatever you want, you can use that component over there. Right. So we will be covering mostly the sprite components because this is where the animation and the character building takes place. Right. Components has this one factor called as priority. Now priority means like we have multiple components from back of the screen to the top of the screen, like start of the screen. So like you want the background at the back, then you want the character, then you want something in front of the character like scores and all. So for that we can use priority in component. That helps us to align the objects in the z-axis, like the z-axis, okay? So which should be at the back, what should be at the front. So this helps us. The add and add all functions helps us to add the components to the game or the world over here in this case, like we have this entire world. and to keep a common reference to the game till the end, like we have multiple components, like we can build n number of components, and to have a common reference of the game, like let's say we have a scoreboard, or let's say we have lives or state levels, we have a has gem ref mixing, which helps us to keep a general what we say, we can align the game properly with each and every component that we have created. Again, as I've said, this is the positioning component, which helps us to position the object wherever we want. And each component that we create, or each sprite that we create, is actually extended from the positioning component. So each and every sprite component will have this positioning component present inside itself. So you don't need to have a different wrapper for your positioning of these sprites. So scale is there to increase and decrease the size. We have angle, we have anchor. If you want your sprite component to stick at the top left, let's say for pause menu, and top right you want for score, so you can use this anchor property in our position component. Now, what is sprite component? As I've said, it's one of the most important component, renders from a single sprite and used to create sprite objects. Now, what is sprite? Like, to create sprite object, we must first understand what is sprite. So, a sprite is a 2D bitmap that is integrated into a screen. So, like there is any bitmap image you want to integrate into a screen, that is called as a sprite. Most often used in video games. It is non-static and it moves independently of the background. So, it's not stuck to the background, like the background can move however it want, but this animation or this sprite will be completely independent. It generally represents characters, power-ups, enemies, collision, or let's say there are some platforms, whatever we have, that would be represented by the sprite or whatever we need in the game. So this is how you actually create a sprite. Like there is this sprite.load function, and then you add the PNG that we have, okay, and we give the positioning of the sprite. So if you want it vector 2, x and y will help to position the sprite from the top left of the screen. So let's say it's 10 and 20, so it will have that much space, and the sprite will be created on the screen. The angle is 0, and at the end we add the player, okay. And this is how the sprite will be. It will be just a simple Mario on the screen doing nothing. It's just a static sprite because images generally don't move. So, but if you see in the game, we actually find that the characters are moving. They are not static. They are not just image. It generally tends to move, or they are animating. So how do we get that? So there is this component called as a sprite animation component. Now, a sprite animation component, what it does is it creates an animation based on multiple sprites, okay. So there is a bitmap image which will have multiple sprite images present, and based on those bitmap images present in a single sprite, it will create the animations. It will take each and every image and it will loop it continuously so that it will create an illusion for us that, okay, the character is moving continuously. Now, there are two ways to create animation. One is sequenced. So now a sequenced sprite animation should have a sprite sheet which will just have one type of animation. For example, if the character is running, it should just have the running animation. It can't have jumping, it can't have in general ducking or any other animations, okay. This is easier to create. You don't have to keep track of much of the things. All you have to do is just use the sprite sheet and just use the sequence constructor to create the animation component. There is another function called as from columns and rows, which helps us to create different types of animations from a single sprite sheet, which will have different sets of animations. So I will just show what sprite sheet actually are. So a sprite sheet is a bitmap image that contains several smaller graphics in a tiled grid arrangement, okay. sprite sheet helps in generating animated sprites component easily, and it helps in improving the performance and reduces memory usage. So that's why instead of having a single sprite image, I would prefer to use sprite sheets for multiple animations, which will speed up the process. So these are sprite sheets. You can see these are grid aligned of Mario. On the left hand side of the image, you can see Mario running to the left. On the right hand side, you can see the Mario running to the right. Then we have jumping Mario, we have the dead Mario as well. Then we have the smaller Mario, the grown up Mario after the power up. So this is the entire one sprite sheet. If we used the sequence animation or the sequence sprite component, it would be difficult for us to segregate the running of the Mario from left to right. The images and the animation will get confused. So for this, we will generally have to use from columns and row, because over here we can actually decide like how many rows and columns are there in our sprite sheet, and for running from which row and which column do I have to actually choose the animation out of the entire sprite sheet, making it look like the character is actually running, or let's say jumping, or over here ducking. Multiple animations we have. Just like there is this single Mario sprite sheet, we also have sprite sheet which contains a lot of different characters as well. Like we have Mario, we have Luigi, we also have the Mario with the power up. Then we have enemies over here, like we have Goomba, we have Red Duck, Green Duck, right? And all these sprite sheets, we have also have the browser over here present at the bottom. So we can select each and every character out of a single sprite sheet and use it into our game. Or we can also crop the sprite sheets and just make it easier for us to use it separately, because you don't have to track again and again the rows and columns of each and every character separately. Or you can just create a constant somewhere and store them, so that you can just call the constants and use the same sprite sheet. Now, this is a way where we can create one animation. For example, the Mario is running, right? But in the game, if you'll see over here, we have the jumping animation. After that, we have the running animation. And once the Mario touches the enemy, he is dead. So there is a dead animation. Now, previously, we just created one animation, that is running or jumping or ducking. But in the game, according to the state of the game, the animation should also change. It's just not like the Mario won't be running from start to end. If it touches the enemy, it should die. If the user presses the jump button, it should jump. So we want something that will also create animations, but will also store multiple animations so that we can use them depending on the state we have. So for that, there is another component called as sprite animation group component. This is the same component as the sprite animation component. The same laws are there, the same functionality as there, but the sprite animation just takes a single animation, but the sprite animation group component takes a map string of all the, of just a map of all the animations. So we can add multiple animations inside a group, and then we can just change the state of our animation, and we can show different kinds of animation on our screen depending which animation we want. Okay. So before we create different types of animations from our sprite sheet, we have to decide what are the different states, so that we can divide the animations according to the states. So for the main character, generally we have the appear state, how the character will appear. Then we have the idle state, like when he's not moving, he's just standing. Okay, when the user is not doing anything, so there is an ideal state. Then we have the running state, jumping state, ducking, falling, shooting, dead. And after dead, we want the disappear state also. Like we don't want the dead character just floating on the screen. So the disappear state as well. And for enemy, it's the same. Like we have appear, idle, then attack, dead, and disappear. So first, now we have created different states in our mind. So now we know how we can divide the sprite sheet. So we will be using columns and rows to create a sprite sheet component. For this function, we need to pass the number of rows and a number of column. Sprite component can be created from the sprite sheet. And to create animation, we pass the sprite number, like from which point to which point do we need the animation, like from, let's say, from 2 to 4, or let's say from 3 to 5. We need the start and the end of the row or the column that we are using so that we can generate the animation. Now, this is a simple explanation about how we can do it. So we just have a single sprite sheet, okay? And you can see at the first, we just have one row so that it will be easier for us to understand. And each row has different types of actions going on. So the first column over there, we have the idle Mario, like he's not doing anything, just idle, okay? From second, third, and fourth, like 2, 3, 4, we have Mario which is running. So the second, like he's just lifting his feet. Third, he has kept both the feet on ground, and on fourth, he has taken up the other feet. So like these are the three animations which will help us to create a running Mario. The fifth one is like when we actually turn, but in this game we are not going to use it. So we can just skip that kind of the fifth column in this row. We are just going to skip it. Then we have the sixth column, which is jumping. When we actually hit the space button or the up arrow, the Mario will jump. So that is the jumping animation. So we will choose sixth column for that. And for ducking, we will have the seventh. For dead and disappear, like disappear, I have a separate kind of animation that I'll be using, and dead I'll be taking from a separate sprite sheet because it was getting very clumpy inside this. So how to create animations? So it is simple, as I've said before. We use from over here, you can see from column and rows function, and we pass the image. So we have characters Mario.png present. So this is the sprite sheet that I've used to create the animated Mario. I pass one row and the number of columns are 7. If you can see, we have 7 columns. That why one row, 7 columns. So it knows what it has to take. Then after that, we use the create animation function inside the sprite sheet to actually create animation. And that create animation function requires some parameters. One is the step time. Step time means how fast you want the animation to run. So like if you keep 1, it will be too slow, 200, 300, what you want. Okay, depending the speed, you can adjust it. I don't remember what I've kept right now, but at the end, I'll surely let you know. And the to and from. So if you can see, for the idle animation, I have used from 0 to 1. So 0, that means nothing. We have to give the previous number as well. So 0 to 1 is idle. Then running is, if you'll check over here, the running is from 1 to 3. This is the running. Then we have jumping animation. Then we have the ducking animations. Okay. And also the loop is true. Why the loop is true? So that after the animation ends, we want the animation to restart. Okay, we just don't want the animation to stop over there. So that's why the loop part is true over there. So this is how we create a sprite sheet. And once we create the multiple sprite animations, I've also created an enum to keep a track of the Mario state. So idle, running, jumping, falling, and ducking. And just like that, I've added all these animations inside a group so that I can change the state of my character. And the current state at the bottom, I have passed that as running. So whenever we have the Mario on the ground, it will just start with the running state. Okay? Any questions or doubts till now? Fine? Yeah. Okay, as I've said, once we create the component, we have to add the component to the world. So this is where the onload function I'm using of the game that I've created. Okay, the game class, Mario Run. And over there, I'm adding my Mario inside the components like add Mario. And if I just run the application right there itself, all I can see is Mario. This is a screenshot, but if you'll run, you will see the Mario just walking or running just into a void over there. because there is no background, there is nothing. We just have had one simple Mario running into void, nothing much, okay? And it doesn't look appealing at all. So for that, we will just add a parallax background. So parallax background is something where the background keeps on moving at the back and your character is there, and it gives a running look and feel for the character in front. And one of the most important thing of parallax background is the objects which are closer to you, they move faster, and the objects which are behind you, they move pretty slow. So each and every layer has different set of speed that we have, okay? So to create a parallax background, first thing is that we will need multiple layers of a single image, like which is the first image, the platform where the Mario will actually run, then the background, one, two, three different kinds of background, then the sky at the end. So this is kind of, it's up to you how many layers you want. Generally, 4 to 5 layers make a pretty good parallax background over here. So I have created a folder called as parallax inside assets, and I have added all the parallax backgrounds that I have, like from 0 to 6 generally, okay? And these are the different layers for the layers that you will see inside the entire background that we are going to build, okay? And yeah, this is how we create a parallax component. I know it's a lot of code, but just a single line repeated again and again so that we can create an image layer, okay? So first thing, we have to load parallax image from our game, and we have to pass the path. So that is parallax and PBG, like parallax background 0 PNG, okay? And we are going to repeat that image. Why? Because once the image goes out of the screen, I want the same image repeating again and again. That's why I'm going to repeat it in an x-axis, okay? Repeat x, and layer fill will be the height. So whatever height of the screen, I want the image to take the entire height. So like it matches my screen size. Okay, x-axis left to right, y-axis top to bottom. So I want the image to repeat from left to right, not from top to bottom. That's why I have given repeat x. If you have a game where you have a shooter and you're going up to the sky, you can use repeat y, so that the image will repeat from top to bottom, like a scrolling behavior. So it's up to you how we use it, okay? And for the end layer, I have given layer fill none, because I just want the platform at the bottom side, and I don't want the platform to take the entire height of the screen. That's why all the images will have the entire height, so fill will be layer height, but the platform which is at the end will just be none. So whatever height is the platform, whatever the height of the image of the platform is, it will be just layered to that height, but of course the repeat will be on, so that we will have the continuous platform. And then I will add all those platform into my layers file, and each and every platform will have a different velocity depending on the index value they are, okay? So the front index will, the front background will have the maximum speed, and as we go back, the speed will get on decreased, like I'm multiplying the speed by 0.5, so the speed will become half, half, half as we go back. So the front will be faster, and the back will be, the speed will be 0.5 of the previous speed. So this is how we get the parallax at the end. So you can see we have like 1, 2, 3, 4, 5 layers going on, and this will keep on repeating till the character dies or till we stop the game, okay? But if you notice, the Mario was missing, because for recording the video I forgot to add the Mario. But if you'll notice, if we just merge two images, like the previous one where we have the Mario on screen and this parallax image, you will find the Mario still on the top running but not at the bottom. And the main reason behind that is like there is no gravity. We gave the position of Mario to come onto the screen, but we never gave gravity. So whatever position we gave at the start, the Mario will be there itself. So we need gravity so that Mario will fall from top to the bottom, and then he will start running. and whatever objects are there on top, if we give gravity to them, they will fall. So how we give gravity? Simple. We just add the velocity dot y. So the y velocity increases with any factor you want. Generally, I like to keep gravity 9.8 because that's what it is here on Earth, but you can have whatever gravity you want. And we can just keep on updating the gravity with the update function. I'll just show you how to do it. So to add the gravity, we increment the velocity y with the gravity value, that is 9.8. Now we have the speed. We just apply gravity. So velocity dot y, and we are incrementing it, not just adding it once, but we are continuously incrementing it with gravity, which is 9.8, and position dot y. So now the position of the Mario with the y axis, okay, we are going to give velocity dot y and multiplied by dt. dt is the delta time. So update function has a value called as dt or delta time, which updates the frame per second. So delta time is per second, or let's say per tick in this game development term. So with each tick, this function will be called and dt will keep on increasing. That will help us to increase the speed of the Mario falling down. Because if you see, gravity is 9.8 meter per second. So per second, the 9.8 will keep on incrementing. So that effect I have to give. That's why I have multiplied it by dt. And there is one more concept called as terminal velocity. Like after a level of speed you have achieved, the speed won't increase. I have not given that, but if you want, you can just write an if-else case. Like if velocity dot y increases more than 500, then you don't want to increase it any further to give terminal velocity, or you can just clamp the velocity with 500, 400, whichever value suits you. It's up to you. But over here right now, it will just keep on falling. If we have a huge screen, after some time, the speed will increase way too fast, okay? Now you can see the Mario, we got the gravity, but let me just try it once again. We have the gravity, but then the Mario completely falls off the ground. Like there is nothing to hold the Mario on the platform, and it's a pretty bad UI if you can't just play. And the main reason behind that is it's not colliding with the ground because there is no collision given. It's just running, it's just falling with the gravity and poof, dead. Okay, so now we have to give collision. So like we covered gravity, we covered creating of components, and now the major factor is adding collision. Collision is one of the most important factor in game development because without collision you cannot kill enemy, you cannot jump, you cannot collect points, you can't do anything, you can't even play the game. So yeah, collision helps us to detect when there is an interaction between two components or the two sprites on the screen. And what are the types of collision that we are going to need? One is when the character collides on the ground. The second is when the character collides with enemies or traps. And third, when the character collides with some of the power-ups, like we have coins or mushrooms, like whatever we have. So these are generally the three types of collisions we require. Okay, so to add collision into our application or into our game, we must first extend our main Mario run with has collision detection, which will give us the detection throughout our game, so that no matter which component we have, the detection will be present. Okay, and now we just have to give the collision to the last, or let's say to the first layer that we see, the background, the platform that we have, so that the Mario, when it will fall, it will just fall on that layer. That layer will have collision and not the rest of the background, because else it would be running on the trees and not on the platform. So this is how we add collision. First, we try to get the last layer, because we added the platform layer at the last. We try to get that last layer from our parallax component, and then we add collision just to that component, and we give the height of the Mario. So we add collision, we give the height minus the height of the Mario, so that the collision will increase, will come on top, so that the Mario won't go at the bottom over there. And for the width, I just took the entire size of the game. So like game.size.x, which gives the entire platform the collision. No matter where we go, it will have a platform and it won't fall off in between. So this is how we create a general collision for the platform. And we have to add that collision to the Mario as well. So first thing, we have to make sure that if velocity dot y is equal to 0, like first, if velocity dot y is greater than 0, that means Mario is falling, right? So first thing we have to make sure is we have to turn that to 0. That's why velocity dot y is 0. Now the position dot y of Mario, the position that I want should be the position of the platform. So block dot position dot y. Now the block over here is the collision block of the parallax background that I have created minus the height of the Mario, so that the Mario will automatically come on top of the platform and it won't go below the platform. Okay, and then the current state is, I'm changing the state of Mario to running, and I've also created a Boolean value which is stating that is on ground is equal to true. So we know that currently the Mario that I have, that is on ground, so it is running. Then we also have is jumped when he is jumping, so that we can just change the states and also do other factors that we want to do in this game development. Now when the Mario runs, you can see it is actually just running. Okay, this is a good layout, but still pretty bad because there is nothing we can do. There are no enemies, there is no coins, no power-ups, nothing. Just like we added Mario, we created a sprite sheet of the Mario, then we added the Mario. We have to just keep on repeating the same steps again and again so that we will create multiple components. The way we added Mario, we just have to add enemies, and I've just created a function called as spawn enemy, which will just keep on adding enemies on the screen after every 3 seconds. I've created a list of types of enemies and create a random number out of it. If 0, 1, 2, 3 and whatever list is present in the type of enemies, it will just create a random number out of that. And if it's a Goomba, it will create a Goomba. If it is duck, it will just spawn a duck in 3 seconds. So this is the function I've created, an enemy manager, which will just run on every trick and just spawn multiple enemies. And again, we have to add the parallax background and the enemy manager to the screen, or let's say to the game over here. Now we added the enemies, we also have to give them the collision. So the same again, we have to use collision block. We have to give the width and height and the size to the collision block. Again, we have to add this collision block to the collision blocks of our Mario component so that we can distinguish if it is a platform, if it is enemy, if it is power up, depending on what type of collision it is. I want to make sure what things are happening. For example, if it is platform, run. If it is enemy, die. If it is power up, increase the power up. Okay. So how Mario will react with the collision? If Mario is on ground and the the state of the enemy is walking, and then if the Mario collides with that, then I want Mario's current state to be dead. So the Mario will die. Got hit by enemy is true, and after that I want Mario to disappear. Then I'm giving a delay of 4 milliseconds and I'm removing Mario from parent, like there is no Mario on screen. That's how it would be. The last and the most important factor, like the Mario is running, we get hit by the enemy, we die, we can't help, we can't save Mario, we can't survive. So for that we need character control. So over here I have given the keyboard control where we have created horizontal movement. If we press the right button, the Mario will run to the right. If we press the left button, it's not working right now, but yeah, it will come to the left side, but there is no left side animation. And the space bar or the up arrow will help Mario jump. We have given a jump force of 350 so that the velocity will be like he will jump with the force of 350 over here. So this is just a normal function which will help. And there is this function which is called as update player movement. So if has jumped and is on ground is true, then the Mario jump function will be called. Velocity.y, gravity, just simple mathematics functions that you can play along and decide how Mario should jump or move around. It's up to you, like how it works. And this is how the jump function I've created. Velocity.y is equal to minus the jump function. So y is the positioning, like the speed, what it's coming down, like minus the jump force, it will just go that much speed on top over there. And I'm just updating the position again and multiplying it with the delta time. Hash jumped is false, is ground is false. Again, is on ground is important because when detecting collision with enemies, if Mario is on ground is false, then I will kill the enemy and not the Mario. But if is on ground is true and then Mario collides with the enemy, then Mario dies, not the enemy. Okay, so this Boolean value is important for the Mario to survive as well. Hash jump is important. So like we have this over here. You can see now the Mario can move left and right, which it will jump. Again, there are some purple boxes. That is a debug mode, which will actually helps us to study how much is the size of the collision and what, like the image is different, and we need to actually get the proper size of the collision or the hitbox. That's why we have to create a separate box around it, because sometimes like with cropping go bad, the image might be small, but there might be a gray area around. So we don't want that. We just want the actual size of the sprite or the bitmap. So that's why we need it. And at the end, just one final part is adding sound. Without sound, this game is actually very boring. There's nothing much. There is no proper Mario theme that we generally like it. So we'll use the Flame audio package that is there just to add sound. It is simple. I have all the sounds present, like coin collect, death, enemy death, game over, like whatever sounds we have from the original Mario. Just drop them down in one folder. There is this theme called as Mario theme, which is a background music which will run continuously in loop. So we have flame audio dot BGM background music, and I'm playing the Mario theme with this volume. So I've created a component called as play sound. If true, it will play sound. If that is false, the sound would be played. So in settings, you can turn or you can toggle the sound on and off. And I've also had a value called as sound volume. So I can alter the, like I give a user a menu where he can switch or he can turn up the volume or turn down the volume in settings. And simple, if game.play sound, this is where Mario jump function is called. If this function is called, play the jump with the volume provided, and the rest of the function is working same as it is. And yeah, that's it. Thank you, Mario, for but a princess is in another castle. Simple. If you want, you can, I have uploaded this to Git, and you can just clone the repo from there. And this is without the debug mode. So we can just run. There is this one coin. And this is how it dies. Simple. Yeah, that's it. That's my talk. I hope it was interesting and you guys had a lot of fun. Thank you.